All right, welcome to the second example and the last example for chapter 13.2. All right, so we have a study of chromosome abnormalities, and Criminality examined data from 4,124 males born in Copenhagen. Each man was classified as having a criminal record or not, using the registers maintained in the local police offices. Each was also classified as having the normal male XY chromosome pair or one of the abnormalities, XYY or XXY. Of the 4,096 men with normal chromosomes, 381 had criminal records, while 8 of the 28 with abnormal chromosomes have criminal records. Some experts believe chromosome abnormalities are associated with increased criminality. All right, here we go. So the first thing, we need to define each proportion, and we need to state what our parameter is, what we are interested in. All right, here we go. So first of all, I state this. The two populations are Danish males with normal chromosomes and Danish males with chromosome abnormalities. So that is our population of interest. Okay, defining it. Now, in this one, okay, you don't always have to use numbers. You don't always have to use p sub 1. You don't always have to use p sub 2. You might want to label it with something else that gives you more of a reference to what we're talking about. So here in this problem, I used p sub n, obviously for normal, and p sub a for abnormal. Okay, it might be a little bit easier to keep track that way. So I've defined what each of those is. All right, now my hypothesis. So again, we're saying that they're the same. The proportion for normal and the proportion for abnormal are the same, versus the alternative where the normal is less likely to be a criminal than the abnormal. Okay? Now, if you start with Pn, P sub n equals in the hypothesis, if you start with P sub n equals P sub a, you have to do P sub n, P sub a. Okay, don't switch those around. So P sub n is going to be less than the P sub a for the abnormal. All right, so there's step one is done. Okay, again, SRS. We must be willing to treat each of the two samples as an SRS from the respective population of interest. We are not told it is, we are not told it is, so it is, we are not told it is, so we will proceed with caution. Normality. Again, we have to combine the proportions. So the combined proportion for those having criminal records, that the 381 plus 8 divided by the 4,096 plus 28. So since the combined proportion equals 386.25, the normal times that, and the abnormal times that proportion is 2.64, and then the complement of both. Okay, now you'll notice that this one right here was 2.64. Uh-oh. Okay, remember it's supposed to be at least 5. Again, don't forget, at any time you can pause this to look at it a little bit more carefully if I'm going too fast. Okay, so we're taking another risk using the two proportion z-test, since one of these values is less than 5. So the SRS and the normality don't quite live up to what we need them to live up to. All right, independence. In order to use the standard deviation, the population of each needs to be at least 10 times the sample size. There needs to be at least 10 times, or 40,960 Danish males with normal chromosomes, and at least 280 Danish males with abnormal chromosomes. Okay, going through the math. Again, put the data into your calculator. So again, stat test. This is number 6. All right, plug the numbers in. So again, 381 and 4,096. $8 and $28. And our alternative up above was less than. The normal was less than. Calculate. Boom. There's all the information that we need. All right. Plug your numbers in. Again, you can see from the calculator. Okay, I think I messed up. Hold on. Aha. 4,000. Okay, let me double check that again. Sorry, ladies and gentlemen. 4,096. I forgot the 0. 4,096. I knew that was a little bit off. My apologies. Okay. Let's go back and double check that again. 381, 4,096, 828. Calculate. Okay, much better. So you can see p hat sub 1 matches, 0.093. P hat sub 2, 0.2857. Okay, plug your numbers into your z value. And again, don't forget, this is p hat 1. This is, well, in this case, it's p hat n. This is p hat a. This is your p hat combined. Your p hat combined. Your n1 and your n2. Okay, just backload it in. Here's your z value. There's your p value. So the p value is 0.0003. Very, very significant. Write our conclusion with a p-value of 0.0003. There is strong evidence to conclude that the proportion of criminals is higher among Danish males with chromosome abnormalities. However, this conclusion may not be valid because the SRS and normality conditions were not met. All right. Next, we're going to go ahead and construct a 95% confidence interval. So again, the condition for normality is different. So we need to go through and redo the normality condition. If this was on the AP test and they ask you to do this, just like we're outlining it here, you would have to go back and you would have to check the conditions. Now, the conditions when we do a confidence interval are all met. Okay, you can see that they are all 5 or greater. Okay, look at it carefully, think about it. So we get this confidence interval, or plug our numbers in. Again, you can go to the calculator, it'll spit this out for you. Okay, p hat sub 1, or a, or n, p hat sub a, p hat sub n, times its complement, p hat sub a times its complement, all over, so over its sample size and over its sample size. And this is the confidence interval we get. Okay, you need to wrap this up. My time is almost up. We are 95% confident that the proportion of Danish males with criminal records is between 2.5% and 36% higher for those having chromosome abnormalities than those who don't. Okay? Again, look at it carefully. You probably could word that another way. You could probably say 2.5% and 30% lower for those who have normal chromosomes. Okay, but I would stick with this one. All right, hopefully that helps. I did make a few typos. I am now going to need to go back and correct them before the lesson in class. Thank you. Hopefully you are all having a great time.